Hey everybody, how's it going? My name is Attila, and in this video we're going to talk about the Euclidean distance function in pgvector. In the previous two videos we discussed the negative inner product function and the cosine distance function. So in this video we are going to look at the Euclidean distance, or how you can find it in the pgvector readme L2 distance function. So once again we are starting with an example. So let's say we have these two vectors. We have a green vector, a blue vector. What we are going to look at here is the distance between these 2 points. So if you remember, in the previous videos, we looked at the cosine that looked at the angle. Then we looked at the dot product function, which looked at the angle and the length of the magnitudes of the vectors. In the case of the Euclidean distance, we're going to look at the distance between these 2 points. The distance between these 2 vectors will determine the similarity between the vectors. Now let's have a quick look at the formula. So in the formula you can see that we are calculating first the difference between the 2 points. So we are using subtraction to do that. Then we are squaring this value, adding them all up, and then finally taking the square root of this number, and that's going to be the distance between the 2 points. When it comes to the range of this formula, the minimum value will be 0, in which case the distance will be 0, and that means that the 2 points are in the exact same position. Obviously, negative distance doesn't make sense here. Now, when it comes to the maximum end of the range, there is not really a maximum. It all depends on the vectors. Now, let's look at the implementation of this formula in pgvector. So there's a function in pgvector called vector L2 square distance, which contains the implementation of this similarity function. So let's quickly pull up the formula just as a reminder. So as you can see here, similar to all the other functions, we are iterating over all the dimensions of both vectors. The first thing that we are doing in this iteration is, again, according to the formula, we are doing this subtraction. So we are calculating the difference between the 2 numbers. Then in the next step, we are squaring up this number, and then finally adding them all up, summing them all up in the distance value. So this function will return the distance value, but it actually returns the squared distance as the name of the function suggests. So because of this, there is another function which is the actual L2 distance function, and this is calling the previous function, and then it's also taking the square root of that number, so we get the actual distance between the vectors. All right, that's all I wanted to share today. I hope that was easy to understand, and I see you in the next one. Bye.